Hey everybody, for those of you who don't know me, my name's Tygan Loxon. I'm a paraglider pilot and a sailplane instructor at the Boulder Municipal Airport. I'm out here at the National Center for Atmospheric Research just above Boulder, Colorado, and it's currently gusting to 65. So gotta watch my camera a little bit because it's really cranking. But I wanted to talk about how quick the weather changes here in Boulder and how to keep yourself safe while you're flying. So literally 2 hours ago, the sky was perfectly blue and there was light and variable winds from the east. And now the sky is filled with clouds. We've got gusts up to 65 miles an hour, and it's definitely not something you want to be flying in. So I'm going to show you how to use a website I put together to make sure you're safe to fly and to check the forecast.
Hey everybody, so it was a little too windy out there, so I decided to move into my workshop out here in the garage to show you my weather website. So if you find this video useful, took me a bit of time to make, and it took me quite a bit of time to make this weather website, so I'd appreciate a donation, but I really want this information to be available out there for free. So if you don't feel like you want to make a donation, that's completely fine. Enjoy this video. Also feel free to ask me any questions about it afterwards. All right, so let's get started. So right off the bat, this is the forecast from windy.com. It's a pretty nice quick overview just to see, like, can I fly tomorrow? So for example, today's Sunday, it's Sunday evening, and looking at tomorrow, I can see that the winds are going to be 18 gusting to 48, so it's not looking like too good of a day. It's also going to be 25. But this is pretty easy to check. You can see out a bit in the future. But yeah, this is pretty nice for just checking. It also it tells you the wind directions here. So scrolling down, one of the most important live weather that I think that they have here in Boulder is the winds at NCAR. NCAR is where I did the video at the beginning of this. It's located about 600 feet above Boulder, and it's right near the Flatirons. The nice thing about it being 600 feet above Boulder is the fact that it kind of picks up the wind that isn't being disturbed by the surface friction. So it kind of gives you an early warning before the winds switch on the ground. So all of these links on my website, if you click them, it will take you to the website that they came from, and you can scroll through this, but I'll just show you what it is on my website. So the three main things I take from this is the wind speed, the direction, and the temperature and dew point. So these charts show what's been going on in the last 24 hours. So as you can see, this morning it was pretty calm. It was 10, gusting 20, like here later in the day. And honestly, it seemed like a really good day to fly. I'll try to attach a picture of one of the pictures I took earlier. There's a bunch of people out kiting their paragliders today. It was perfectly blue, not a cloud in the sky. Then slowly we started seeing some rotor clouds come in, and then it started switching on the ground. As you can see here, it started gusting to 70 miles per hour in the afternoon. So what I'm checking for here is, what's the trend? Is it looking like it's getting worse? Is it getting better? If I look on here and I see that it's been gusting to 40 in the last hour, I'll definitely take a second look at whether I'm going to fly a sailplane, and I definitely wouldn't fly a paraglider. Down here is kind of nice. It shows the wind direction. When it's really strong out of the west, generally, or like the strong winds that are dangerous to fly, generally you'll see it kind of look like this, where they'll form a line. And then as it starts kind of changing directions, you'll see it scatter a bit. Obviously for paragliding, we want it to be anywhere from the south to the north. We don't want it with any west component, because then we're in the rotor of the mountains. So this one right here is pretty handy as far as being able to tell how many clouds there are, or if there's going to be fog. It also is a good indicator of whether there's a Fern wind. So if you don't know what a Fern wind is, I'll try to make a video on that. But basically, a Fern wind occurs when there's some strong mountain wave and it's causing the temperature and dew point to spread apart. So right now, the last 24 hours, we're seeing a pretty far spread between the temperature and the dew point here. The temperature is the red line. The temperature is never lower than the dew point. If it's lower than the dew point, it basically is raining or already super wet, and the dew point comes down. But I'll explain more about that in another video. I'm assuming in this that you kind of have a general idea of what all these weather terminologies are. So down here you see the dew point is 5 degrees So it's a pretty far spread between these two, which means it's pretty dry. That's probably like 15% humidity out here. As the wind started to pick up this afternoon, we started to notice right as it was starting to pick up, the temperature started dropping. Now this is midday. It's not from there being some kind of cooling. So you see that there was like some kind of front coming through. Also the dew point started coming up. And as you saw in the video, it started getting cloudy and really windy. So this is a good indicator. If it's the middle of the day and all of a sudden you see the temperature drop, you know there's some kind of cold front or something coming through. A Fern wind, you'll see the opposite. You'll see like the temperature and dew point kind of close together, and then they'll come through and spread out as it gets closer to the actual current time. So coming down, I explained what Weather Underground site data is. I try to do kind of a brief explanation written for each of these sections, but I figured I'd do this video to make it more thorough. But basically, Weather Underground is anybody who buys a weather station can put the data from their weather station online. Now, sometimes these are really good, sometimes they're bad. They're bad if, like, for example, I bought one of these stations and I decided to just put it up in my backyard and there's fences and trees all around. It's not going to get the actual proper wind data. So these three I found are pretty useful for this area. North Boulder Ridge, which is located, I'll show you. All right, so here's the town of Boulder. The Boulder Airport's here. The paragliding hill is right here. North Boulder Ridge Station is located just on the top of this hill. So it's right at the top. It's at 6,500 feet. So it gives you a pretty good indicator of what's going on launch. So for paragliding, this is the first thing you look at to see whether it's flyable. Now, just because this says the wind is coming in from the east doesn't mean it's flyable. For example, right now it's saying the wind is 5 miles per hour gusting to 6 north-northeast. Now, that would seem like it's flyable, but coming up here and looking at the winds, it's gusting to 40 at NCAR. So it's either in the rotor or the wind's not touching down at that point. But this is why you want to have an overall broad picture of what's going on. Looking at downtown Nederland, 8 miles per hour gusting to 19 east-southeast. And Ward looks like it's not working. So if it shows this, it's not working. So if you want more information, you can click the link at the top of that, and it will take you to the page. Similar to the NCAR one, you can see what's been happening in the last 24 hours with the summary here, with the highs and the lows as far as temperature. Let's see. Down here, there's data for what's been happening in the last 24 hours, I believe. Yep, last 24 hours. You can see the temperature and dew point here. You can see the wind direction and peak wind, so like the gusts. So we can see earlier today it was hitting 45 there. You can see the wind direction here, and you can see the atmosphere or the barometric pressure here. So going back to my page. These two look the same, it's just for a different station. Now this one's pretty interesting. It's the live winds aloft for Denver International Airport. If it says ND, that means it currently doesn't have data for that point. This sometimes has absolutely no data on it whatsoever, and sometimes it's completely filled out. The way this works, I believe, is they've got a laser that goes up and hits different particles floating through the air, and they can detect how fast the wind is. I've heard from different sources that this is moderately reliable, that sometimes it's not super accurate. I don't know exactly what that means, whether it's maybe the wind speed slightly more or slightly less. But I would say this is a good rule, like sanity check to see at what heights the winds are coming out of the west or what height the winds are coming out of the east. So coming down a little farther, we see the winds aloft for Denver. So for my sailplane students, if you were to call and get a weather briefing, 1-800-WX-BRIEF, and you ask for the winds aloft, they would give you these exact numbers. So twice a day at 6 a.m. and 6 p.m. they'll send up a weather balloon to get a sounding, and they will detect what the winds are at 9,000, 12,000, and 18,000 feet. So looking at this, when they sent up the balloon, which I believe this one was at 6 p.m. today. The winds at 9,000 feet were 290 at 39 knots, 12,260 at 24 knots, and 18,230 at 32 knots. Now, I would not say that this is super reliable. It's kind of outdated because this happened quite a while ago. It's now 10:50 p.m. So it's had quite a bit of time for a lot of stuff to change. But this is, again, like kind of a quick sanity check. You can see what has been happening or what was happening then. This is also just for one location and at one time when they sent up the balloon. Coming down a little farther, we have the MesoWest map. So if I click this, this is a little different from that weather underground data I showed you. So this is the location of a bunch of professional AWOS stations, or automatic weather observation system stations. And the difference between these and the weather underground is these are set up by professionals, so they make sure that there's no trees or anything that are going to be affecting the readings. Also, I believe they take wind readings 10 meters above the ground to take away from the ground friction, so this kind of gives you a pretty good idea of what the winds are doing. So they have one here at the Boulder Municipal Airport. So currently winds are out of the west, 14, gusting to 20. Erie Municipal Airport, so you can just go around and look at the different airports here and see what the winds are doing. This is also good if there's a front coming through. You can see when the wind shifts directions. This also tells you the temperature, so you can see a temperature drop and you know that front's coming through. So Greeley out here, it's gusting to 43, and Sterling, you can't see that. So, but yeah, one of the ones I really check on this is Berthoud Pass. Now, don't be afraid when you see the numbers on this, because it's always saying it's pretty windy up there. So currently, it's actually not saying what the winds are. Okay, so generally this says what the winds are doing on Berthoud Pass, but it might have been too windy for it, and the wind might have broke the detector because they're not reporting it. Coming down, it shows a history of what was going on. So it looks like at 8:12, the wind speed quit reporting. It was actually a bit lower than I was expecting. Earlier today, it was gusting. Down here, it was gusting in the 50s. But this kind of gives you an idea of what the winds are doing at the Continental Divide. So this is right at the Continental Divide at a weather station up there. Coming down a little farther, aviation weather Prog charts. So this is one of my favorite tools as far as seeing the big picture of what's going on. So the way you read a Prog chart is the H's here represent areas of high pressure. The L's represent areas of low pressure. These lines here are troughs, so they're kind of an area of low pressure here. If you see blue kind of cones or blue lines like this is a cold front, and these right here are warm fronts. So obviously down here it tells you it's kind of a key of what's going on. But these gray lines right here are what's called isobars. So you can kind of think of this as a topographic map. So on areas of a topographic map where the lines are really close, you can expect steep terrain. On this, areas where the lines are close together is a steep pressure gradient. So here is significantly different from the pressure here. So if you have a large pressure change, the air is going to want to go from high pressure to low pressure. So along the surface, you can pretty much expect it to go from the highs to the lows. So down here in Colorado, we see these lines are really, really close together, and they are parallel with the Continental Divide. They're heading north-south, so I would expect down near the surface for there to be a west wind. Now, as you go up higher, the Coriolis force begins to affect the wind, and the wind will circle clockwise around high pressure zones and counterclockwise around low pressure. So this works out to where you can figure out what the winds are doing up higher. So in this area, it's going clockwise around the high pressure, counterclockwise around the low. So I would expect the wind to be coming down through here. So over here up high, I'm expecting more of a north wind. So the way you can translate this directly on the surface, it's probably going to be coming more out of the west, but as you get up higher, there's going to begin to get more of a north component for the Colorado area. So that's what I'm looking at here. You can see when these cold fronts are going to pass by coming up here and clicking this button. You can see what is forecasted to happen. As you can see here, generally when these cold fronts come through, they start getting rain just ahead of them, and as we're starting to get into spring, you'll start getting severe weather. These are good and bad for soaring. They usually make it really unstable, but sometimes they cause quite a bit of a wind change. So it can be either really turbulent or pretty violent. In the spring, this is the type of thing you'll see the most severe weather from. So this is what you'll get squall line thunderstorms from along cold fronts. So as one comes through, you can expect severe weather. So it's pretty good to just look at this just to get what the general idea is. So if I'm trying to figure out if we'll be able to fly this week, I come on here and I look throughout the week. It's looking like tomorrow is going to be still pretty windy out of the west because there's pretty close lines. Just to continue on with the close lines, out here is an area where there's not very close lines, so I'd expect there not to be much wind out here. But looking into the future, I'm still seeing these lines are fairly close. As this high pressure starts moving in around Wednesday, it'll start getting nicer. The bars are pretty far apart, so there's going to be a lot less wind. And as high pressure is coming in, it might actually get fairly good for soaring later in the week around Thursday. So we will go back to the website, close out of these, and cool. Alright, so the next thing is the Aviation Weather Jetstream. So this shows the position of the Jetstream, and there's a lot you can go into with this. The Jetstream generally is what causes the high pressures and low pressures, but I'm not really going to get into that. The thing you can know with the Jetstream is if it's directly over you, you're probably going to get quite a bit of stronger winds on at the surface. It'll influence the weather. It'll bring in like for example today, it'll bring in fronts a lot quicker. So you can look where the jet stream is and get kind of a general idea of what's going on with that. Now one of the most useful tools on here as well is the National Weather Service weather discussion. So if I click here, you can see what, like basically they update this a couple times a day, but the forecaster will explain what is happening. So it'll say like what you're seeing on the Prog chart. So like for today, a cold front had pushed across all of the plains this evening with much cooler air arriving. I'm not going to read this whole thing, but as you go through, it tells you important stuff like peak gusts are going to be 50 to 65 miles per hour. It basically tells you what you can expect throughout the day. I've found the more you read this, the more you learn about the weather that happens here, and you get kind of a better understanding of the Prog charts and what to look for, and you'll start noticing patterns. If you come down, they'll give the short-term forecast, where they'll say this evening through tomorrow, and then you can come down a little farther and they'll talk about the long-term, so Monday through Sunday. So it's pretty cool. They'll actually comment on things that they had forecasted in the long term and the short term and say whether they were right or wrong and explain why. So it's a pretty good way to learn how they forecast stuff and how you can. So as far as being able to tell whether it's a good soaring day, whether there's thermals, there's a few tools that you can use. One of them is put out by the National Weather Service, and if you type in on Google Boulder Soaring Forecast, or if you click this link right here, it will pull you up to this page. So this page is either really good or really bad. So this is saying for Monday, March 5th, the thermal soaring index is good. Maximum rate of lift is 1,700 feet a minute. The maximum height of thermals is 17,299 feet. So just by looking at this, you'd think tomorrow is a good day to go flying, right? But if we come back and just look quickly at this, we see that it's supposed to be gusting to 48 and it's going to be raining and snowing. So already I can kind of throw this forecast out the window. I'm finding it doesn't really work that good in the winter, but in the summer it's generally fairly good. There's also something here that talks about the wave soaring forecast and whether that's good. It's saying Tuesday the wave soaring forecast is going to be good, which I might believe because we were seeing that west winds and that on that Prog chart, it looks like the west wind was going to straighten out and be pretty west. I apologize. I'm trying to be pretty broad and explain this for paraglider pilots and sailplane pilots. But just reading through this is just like another quick reference. Like if I only had 5 minutes to just be able to tell somebody whether I thought it was going to be good or not, you can look at this and kind of get an idea, but it's not going to be that great. Tells you stuff here, sunrise, sunset time. Let's see. Down here is another nice thing to know. It says the freezing level. It says right now the entire air mass is below 32 degrees. But this is handy if you want to know for paragliders, if you're going to need a lot of jackets, or for sailplanes if you have to worry about icing. Down here it tells you the lifted index and the K index. You can read all about those down here at the bottom. So it says what the K index is, and it says what the lifted index is here. So I'd recommend just reading through those. And down here, remember how I said in the earlier part of the video that they send up a weather balloon? This is basically the raw data from the weather balloon. So as they send it up, it goes from 5,500 feet, which is at the surface, all the way up to 50,000 feet. It says the temperature at those heights, the wind direction, the wind speed, and I don't really look at these. I look at the thermal index, which I will explain in another video. I'm going to kind of assume you know what it is. To dumb it down, just in case you didn't, minus numbers are good. The more minus it is, the more unstable it is. So like -7 would mean it's pretty unstable, and if there's a thermal, it'll keep going up. Generally, you're looking for minus numbers down to -3. So this is -3.1. Above that's -2.8. It's starting to get to the point where it's not really unstable enough for you to be able to soar. So I would expect the highest you would go this day would be about 14,000 feet if this was accurate. All right. It says what this model, the time for this model is. So it's saying upper air data numerical model forecast valid for tomorrow at 5 a.m. Mountain Standard Time. Coming down, they also run the model for different times like 8 a.m. and 11. And down here showing the afternoon 2 o'clock and 5 o'clock. So these are fairly good for seeing what the winds are going to be doing at different heights based off their model. Another thing that I found is kind of handy, it tells you here the time of trigger temperature. So a trigger temperature is when you can start expecting the thermals to be working and you to be able to actually soar in them. So this is pretty optimistic. It's saying you can start soaring tomorrow at 9 a.m. So you can take this or leave it. But generally in the summer this is fairly good. In the winter sometimes it's pretty optimistic. So back to my weather website, we just looked at the Boulder Soaring forecast. Now for my sailplane students who are wanting to predict wave, this is another good resource here. I haven't used it that much, but I've found it's kind of interesting. So this peak right here is the Continental Divide. So, and then down here it shows you the distance from the Continental Divide. So it's showing, basically you can kind of think of this as like a single parcel of air as it's flowing through. So it's going down on this side of the divide, and then from the wave action it's going up here. So this is actually looking like a really good wave day, but it's a huge area of lift. So it's looking like almost 20 miles here of just lift, which means there's probably 20 miles of sink over here. Down here represents Boulder. So if you went straight above Boulder, we're probably going to be seeing the top of the wave, or the rotor would be sitting right over Boulder, and if you went slightly into the mountains, you would get into the updraft. I haven't used this that much. The main thing I've used this for is if I see a pretty defined updraft section, I know that there's the possibility for wave. So something interesting to look at. You can play with that. Another interesting one is the Rasp model. If you've ever used XC Skies, this is kind of a free version of XC Skies. I haven't used this that much. I've been told from another sailplane instructor that this is a pretty accurate tool for this area. It's actually modeled and run on a computer by a pilot locally, so they're able to tweak a lot of the data and make the model a lot more accurate. But this overlay right here is basically giving you data on, sorry, I'm going to try to move this over here. It's giving you data on the thermal updraft velocity. So over here on the right side, you're able to see how fast a thermal would be going up in feet per minute. So the areas that are yellow over here, the thermals would be going up at 550 feet a minute. Over here where it's green, you'd see slower rates. Over here in the blue, you're seeing really slow rates, so I would expect it to be too unstable over there. Just gonna move this over here so you can see the other tools. Sorry. So the height of critical updraft strength, this is the highest you can expect to go in a thermal. And we're looking at 12 o'clock tomorrow. Yep, it says right here, valid 12 o'clock Mountain Standard Time on Monday the 5th. So this is actually showing kind of a bubble of stability, more than like in the mountains or out in the flats, kind of over the Denver Boulder area. It highlights different sailplane ports: Air Force Academy, Black Forest Soaring Society, Meadow Lake. So you can kind of get an idea of the different soaring areas. But yeah, we can use this to figure out what time the trigger temperature is going to be. But tomorrow is looking like it's going to be fairly stable in this area. But this is again, the height of critical updraft velocity is the highest that you're expected to go, like you'd be able to soar to. Thermal height is similar, but the thermals might go higher than you're actually able to go, because remember, in a soaring aircraft like a sailplane or a paraglider, you're sinking through the air at anywhere from 120 feet per minute to 200 feet a minute, depending on how high performance your aircraft is. Again, a nice feature about this website is they explain what each of these features are right here. So you can read up on these. Normalized surface sun, so this kind of tells you how much radiation and surface heating you're going to get. You can see surface winds just to get a broad overview of how windy it's going to be at the surface. It's looking like this one doesn't want to load. Okay, neither of those want to load. So cumulus cloud base, where the CU potential is greater than 0. So in the summer, if you're trying to figure out what cloud base is going to be, you can click this and it'll show you how high above sea level that you can expect those clouds. So it's looking like there's not going to be any clouds over Boulder, but over Rocky Mountain National Park, it's looking like the clouds are going to be around 13,000 feet. So you can also look at the sounding. So we can look at the Boulder Sounding. So here's the Boulder Sounding. If you don't know how to read one of these, I'm going to make a separate video for that. Or if I haven't made it yet, you can just look up how to read a SQT chart on YouTube. But just a quick overview or a refresher, the blue line here is the dew point. Red line is the temperature. So you can imagine this is, again, the raw data from that balloon that they sent up for different altitudes. And this particular chart on the left side, they're giving pressure instead of altitude. But generally 850 hectopascals is the height of Boulder. And I don't remember exactly what the I don't want to put the wrong information on my video. Actually, over here it tells you how high they are in feet. So 500 hectopascals is about 18,000 feet, and you can see the scale over here. A nice thing is it also shows you what the winds are doing at the different heights and the direction. So if it's got this triangle on it, that means 50. If it's got a full bar, it means 10. And if it's got a half bar, it is 5. So just looking here, it's 50, 60, 70, 75 miles per hour at 20,000 feet. And the wind is coming from the northwest at 75 miles per hour. Actually, sorry, here is 65 miles an hour. So 50, 65. Okay. So as far as determining whether it's unstable, for it to be unstable, you want the air to cool off very fast as it goes up into the atmosphere. So the higher you go, you want it to be colder. The reason for that is as the sun heats up the ground heats up the air just above the ground, and that warm air will begin to rise. And as it rises, it will expand and cool. It's called adiabatic cooling from the expansion of the gases. And as that happens, it cools at about 3 degrees Celsius per 1,000 feet. So if that parcel of air is cooling and the air doesn't get that cold very fast as you go up, eventually it'll become the same temperature as the surrounding air. So basically the thermal will stop. So you don't want that. So you want the air to cool off as you go up. So this dotted line here represents the rate at which that parcel of air will cool. So for example, sorry, I guess I will explain this. So I'm actually going to pull up a better skew T-chart just because it's easier to read. So I'm going to Google interactive skew T chart. I'm going to go to the Rasp Sounding's website, reposition this so you can see better. So these are the different models. I'm not going to really go into those. I'm just going to click a random one and put in the site KBDU, which is Boulder Municipal Airport. And I'm going to click interactive plot, just get this to pull up. I'll probably end up adding this to my website. So, all right, so let's get into this. These red lines that run this way are temperature lines. So everything along this line is negative 10 degrees Celsius. Everything along this line is 0 degrees Celsius. Everything along this line is 10 degrees Celsius. Sorry, I think I said negative 10 here. This is positive 10, 20, 30, 40. All right. So, for example, if they sent up the balloon and that red line just followed this, that would mean the air stays the exact same temperature as it goes up. But just to read the temperature, at this point, it's along the 0 degree line. Fortunately, this tool will read you the exact temperatures wherever you're putting your mouse. So it's saying it's 2 degrees Celsius or 35 degrees Fahrenheit. As it goes up, once it gets to this height, it's crossing that negative 10 degree line. So I know here it's negative 10 degrees Celsius. Okay. So again, the blue is the dew point. So if I see the temperature and the dew point really far apart, I know there's not going to be any clouds. As they start getting closer together, that's when you have to start worrying about there being some kind of cloud or moisture. Okay? So just looking at this, if we were wondering what would happen on a summer day if we heated up the ground to, well, it's obviously not summer, but I'll just say on this day the max temperature was 45 degrees. So I'm going to click right here, 45 degrees at the ground, which is 5,496 feet. If I click, it draws this pink line right here. So this pink line is drawn parallel to these blue lines right here. So if you didn't have the computer, you would draw this line parallel to these blue lines. And these blue lines represent how fast that parcel of air will cool as it rises. Okay? So that 45 degree thermal will be warmer than the surrounding air. So the surrounding air is 33 degrees, but that thermal bubble is 46 degrees. So it's like, so 46 minus 35, it's 11 degrees warmer than the surrounding air, so it's more buoyant and it'll want to rise. As it rises, it's cooling, but it's still warmer than the surrounding air. So do you see how this line is still to the right, still warmer, still warmer, still warmer, until eventually here, this red line, which is the actual ambient temperature line, starts curving over and it's not getting very cold very fast. So right here is where that thermal would reach the temperature of the ambient air and the thermal wouldn't want to rise anymore. So if this was a thermal, this height is 16,948 feet. So we would know the thermal height based off of this is 16,900 feet. So just to play with this, I'm going to show you, it's a really dry day, so it's kind of hard to demonstrate. So now if we want to determine where cloud base is, we would look at the temperature and dew point at the temperature and dew point at the surface. So the temperature and dew point from the surface will converge at the temperature dew point converging line, which is right here. So again, these gray lines right here are the mixing ratio lines. So if you drew a line from here up along like this, where it intersects this pink line is where the cloud base will form. So this can be confused by these right here. So you might think that the cloud base is where these two are close together. Well, that's true. It's a different type of cloud than what this line's showing you. So for example, say we've got a really moist farm field and it gets hot and then that air starts to rise in a thermal. As that air is rising, it's bringing up the moisture from that field up with it. So we care about how moist that air on the ground is because that air is going up into the sky and cooling until it reaches its dew point. So those converge along this line right here. Okay, so this is where we would see the cloud base. Now something interesting happens when the water condenses, or when the air condenses and turns into a cloud. It no longer cools as fast as it did before. Now it cools at the saturated adiabatic lapse rate, which is 2.5 degrees Celsius per 1,000 feet. Now, that might not seem like a very big deal on this drawing. I'll just show you where the saturated lines are. So this one right here is the saturated adiabatic lapse rate line. So what happens once it condenses, it follows parallel to these lines right here. So do you see this? The pink line starts getting a curve here. So tomorrow it doesn't really make that big of a difference because it's pretty stable and it's not that moist at the surface. So we wouldn't see any type of thunderstorms. So to give you an idea of how high the clouds would be, say it got really hot, say it got up to 55 degrees, cloud base would be at 17,000 feet and the cloud tops would be about 21,000 feet. So the clouds wouldn't get that high, or they wouldn't be very tall. So what'll happen in the summer, usually that dew point's a bit closer, which means that the cloud base will be at about this height, and then it'll follow this line until it gets to here. And then you've got this huge area here of clouds. So if all of a sudden you start getting a cloud that goes up to 36,000 or 31,000 feet, what can you expect? A thunderstorm. So this is how you would predict a thunderstorm with this type of chart. So, but yeah, you can get an idea of whether it's unstable by if this line is very slanted, the red line is very slanted over to the left, you know it's unstable because the red, the ambient temperature is getting pretty cold as you go up. If you see it come over and cross over like this, so if you see it kind of take a turn to the right, you know that at that height, the temperature is either staying the same or maybe getting slightly warmer. This is called a temperature inversion, and usually the thermals don't go above that. Another thing to note about the temperature inversions, if there's west wind or mountain wave, it generally comes down and bounces off those temperature inversions. So that's why in the winter, in the mornings, usually if there's strong winds aloft, you'll get kind of calm winds on the surface. but then later in the day as thermals start mixing up and that inversion breaks, it'll mix down that fast moving air at pi, and you'll start getting gusts around 12 or 1 o'clock. But again, it changes every day. But yeah, you can check this out on the Rasp website. So cool. So I didn't really get too much into what models are in this video, but basically a model is they'll take data from actual weather observations from these balloons or all these weather stations, and they'll plug it into a computer, and they run fluid mechanics software, and they kind of try to predict what's going to happen based off of what is happening and the rules of physics. So different models make different assumptions and are more accurate or less accurate in different areas for different things. So generally what I found for the Boulder area is that the European model is pretty accurate for winds, winds on the surface and winds aloft. Previously, the European model wasn't available. It was a pretty expensive model, but this software or this website called windy.com came out, and they purchased the rights to the European model and they distribute it for free. So this is a really cool tool that we're able to have for free now that we didn't have before. Generally, two other common models in this area are the North American model, or NAM, and the GFS model. So these charts, or these maps right here, show the winds on the European model. So I've put this little picker, supposed to be kind of near the paragliding launch hill, and this is showing current conditions. So the current prevailing wind at the surface that this is saying is 9 miles per hour, and based off the sound outside, it sounds like it is kind of getting a little calmer. This one right here I've got loaded for 10,000 feet, and it's showing it's 43, and this one's 14,000 feet, and it's showing 53. I can look into the future, so if I want to see if I'll be able to fly tomorrow, I can click 9 a.m. tomorrow and see what the wind's doing. It's looking like tomorrow it's going to be out of the west, 19 miles per hour. Now again, this is the base wind. This isn't the gust. Okay? So this data up here at the top is from the same source as down here. So see, this is saying 19 miles per hour for tomorrow at 9, or click 10 a.m. We'll click 9 a.m. I don't think it's going to let me. Okay, we'll pretend this 10 a.m. is pretty close to 9. So coming up here, we see at 9 a.m. it's forecasted to be 18 miles per hour to the west. And that's exactly what it's showing here. All right. So I can click here and get more tools. I can change it to what the wind gust is. So it's saying tomorrow at 9 a.m. it's going to be gusting to 48. If you're going to be manipulating this, though, I find it's easier to jump off my website and go to the real website, windy.com. And sorry, let me go over here so we can see the tools. And I use windy.com to predict what's going on. Sorry, I got a little excited with my... Okay, so here's windy.com. I can zoom in and get different maps. So here's like kind of a more detailed map, topographic map. Here's just kind of a rough map. Down here at the bottom, I can move it to the future. So if we want to look at 10 o'clock tomorrow, I can come over here, click wind gusts. If you click on an area, it'll give you the forecast throughout the day. But if I want to see that wind picker, you can just click again, and it'll tell you at that point on the surface it's forecasted to be gusting to 43. So see, we wanted to see if we can fly on the divide. It's looking like on the ground it's going to be 53 knots, so probably not. Also down here I can change the model. Say I didn't trust the European model. I can see what the North American model is saying. North American model saying it'll be 37 up there. I can click GFS, and the GFS is saying 39.
So it's kind of good to check different models and see what they say and generally kind of interpolate what you think is going to happen. But yeah, you can also, they have all these tools down here, reported wind. So this is showing Boulder Municipal Airport's AWA station, shows other wind stations. So you can play with this and see what's most useful. You can see rain and snow, temperature, clouds, all kinds of stuff. And they have overlays here where they'll show you different paragliding sites. I've heard that they're going to update this more and make it more friendly for paraglider and soaring pilots. So stay tuned. All right, so that was generally the overview of my website and how to read the different parts of it. Like I said, you want to look at the whole picture. So don't just look at one thing like this and that be your forecast of what you think is going to happen. It's good to look here, check the current and past winds at in-car, look at the weather underground stations for North Boulder Ridge, Nederland, and Ward. Glance at this right, and then look at what the winds aloft are doing. And then if you want the large scale view of what's going on, which I generally always try to look at a couple times a week, check out the Prog charts. Another thing, that if you're going to do just one thing, it might be good just to read the National Weather Service weather discussion. This tells you basically what's going to be happening and how windy it's going to be, what type of clouds there's going to be, stuff like that. And then as far as predicting whether it's soarable, you can use the Boulder Soaring forecast. So, all right, guys, hope you found this video useful. So I originally made this website just for myself, so whenever I was going to go paragliding or flying the sailplane, I didn't have to go to like 10 different websites and have to remember all those. So I wanted to put it all in a convenient place to just see it all at once. But I figured it was pretty useful and I'd share it with everybody. I hope you found this video useful, and if you did, I'd appreciate a donation. But like I said, I'm really stoked to give this information out for free, so if you don't feel like you want to donate, then that's perfectly fine. Also, feel free to ask me any questions. I'd be happy to go over any of this stuff and what I've learned. Like I said, I'm not claiming to be an expert, and I'm always open to learning. So yeah, feel free to give me any suggestions. All right, guys, see you on the hill.